unsaturated hydrocarbons. In the previous last slide, you saw saturated hydrocarbons. Now we are going to see unsaturated hydrocarbons. Double and triple bonds relatively react, can form new bonds. So the hydrocarbons which have double bond or triple bond are known as unsaturated hydrocarbons, right? If you see, comparing to that previous definition, I told you each carbon atom should attach with 4 atoms, then that is called as saturated. Here if you take this carbon atom, here I have 1 atom, 2 atom, 3. It is joined only 3, joined with only 3. So there is a possibility it can form another bond, right? There is a possibility. But in case of those hydrocarbons which I have shown already, they cannot form extra bonds because all 4 are already filled. But here you see it has now only 3 molecules, it can form a 4th molecule. If I take this carbon, it has joined only with this carbon and this hydrogen. So only 2. This is bond number 1, this is bond number 2. But I told you it can have bonds with 4 carbon, not 4 carbons, 4 atoms, right? So in that case, what will happen? This bond and this bond will be broken for creating a single bond, right? Single bond. So if you see here, just with the help of the diagram, you can see the double bond, right? So here we have 2 bonds, that's why it is called as double bond. 1 bond, 2 bond, right? And here if you see, we can see that is triple bond, 3 bonds, bond 1, bond 2, bond 3, right? That is triple bond, right? What will happen is when these double bonds or these triple bonds are there, we can break them to form bonds, right? So say for example, I have this triple bond, right? What I can do is I can break it to form another bond. So here if you take this carbon, right? If you take this carbon, it has bond 1, 2, 3 and 4 bonds. It has 4 bonds, right? You need to understand this is 4 bonds, not 4 atoms, right? This is only 2 atoms but 4 bonds. Here only 3 atoms but only 3 atoms but 4 bonds, right? So saturated, you see, if you see, that is 4 atoms as well as 4 bonds, right? So bonds are anyhow going to be same throughout, 4 bonds, but the atoms are going to be, the number of atoms are going to be changed, right? Either we can have 2 atoms or 3 atoms or 4 atoms. So what I was showing is, say for example this one, so we just 2 carbon and hydrogen, right? 2 hydrogen, this is fine. So now if you check in this diagram, right, in the diagram shown by them, I have 1, 2, 3, 4 bonds there, right? Here also 1, 2, 3, 4 bonds there, fine. But in the diagram which I have drawn now, I have only 1, 2 and 3 bonds for this carbon, right? So what I have done is I have broken a joint which is actually been here, right? This bond was actually there, but I broke it. After breaking, what can I do is I can add anything else. Say for example, I am willing to add chlorine, right? I am willing to add chlorine, so we can add chlorine, right? So now if we check 1, 2, 3, 4 bonds are 4, fine, but again the number of atoms are 1, 2 and 3, right? So you need to remember double bonds will have 3 atoms, it can have 4 bonds, right? Triple bonds have 2 atoms but again 4 bonds. Single bond has 4 atoms as well as 4 bonds, right? So number of bond is always going to be same if it is a stable component, but the number of atoms are changing here, right? Now we'll see what is about this unsaturation. So if the bonds can be broken to form a new component, that is known as the unsaturated component, right? So here it was C2H2, right? 2 carbon and 2 hydrogen, C2H2. But what happened when I put this chlorine is, just an example, this one bond is broken to accept that chlorine. This one bond is broken to accept that chlorine. So with that broken bond, so now I had 3 bonds, it's broken to 2. So now what we have is C2H2 Cl2. This is after breaking one bond. But story is not ended here. We have another bond, right? We have 2 bonds. So we can break one more bond also, right? So what I can do is I will break this bond also. So if I break this bond, I will have something here and I will have something here, right? So in this I can say, for example, I will add F, right? I will add F. So actually I need to show this is only one bond. I am adding F here also. I am adding F, right? So if you take this carbon now, it has 1, 2, 3 and 4 bonds, right? That is fine. This carbon also 1, 2, 3, 4. 4 bonds are there. But if you check now, 4 bonds are there. 4 bonds are always there. Number of atoms, this carbon has, right, this carbon has 1 fluorine, 1 hydrogen and 1 chlorine. That is 3 plus 1 carbon. That is 4 bonds. If I take this carbon, which is connected with carbon number 1, hydrogen number 1, fluorine number 1 and chlorine number 1. So that is totally 4, right? 4 atoms we can simply join by breaking the bonds. So this is why the compounds or hydrocarbons which has 2 bond and 3 bond, that is double bond and triple bond, are said as unsaturated hydrocarbons, right? Unsaturation means you can break the bonds if it is necessary to form a saturated hydrocarbon. In the case of previous one, that is 4 bonds and 4 atoms, right? So there you can't do anything. You can't add, though you can remove, or you can't do anything. But in this case, you have double bond, so you can break it, right? You can break it to form the single, what is this? Single bond, right? So this is what known as such unsaturated hydrocarbons. So unsaturated of anything, not only hydrocarbon, unsaturated hydrocarbons means hydrocarbons which have double and triple bond, right? So double and triple bonds are relatively reactive and can form new bonds. So why these are forming bond is these double and triple bonds are kind of reactive. So they are they have tendency to react. They are willing to react. So similar case here, if it is single bond, that will not go much into this reaction thing. But if it has double or triple bond, that will definitely go on reaction to break up this bond, right? Break up this bond and to join new people on that, right? So double bond is ethylene or ethylene. So here's a double bond. Give an example. This is ethylene, right? Ethylene. Similarly here, that is C2H2, that is ethine, right? So you need to be very careful in, while naming also, right? The previous one, that is C2H6. So which is coming in the formula C2H2, I mean C2 CnH2n plus 2, right? I'm talking about that formula. That is C2H6. This is known as ethane. Ethane. All right. And I have the other component C2H4, right? C2H4, that is this one. All right. So this has a formula of C2H2n, right? This has a formula of C2H2n. This is known as ethylene or ethene, right? This is known as, easy to compare if I write it as ethene, ATHENE. All right. Then I have this component which can be written as C2H2. This can be written as ethine. So here the formula is C2H2n minus 2. So the first case C2H2n plus 2, then it is C2H2n, then it is C2H2n minus 2, right? And while naming, you see this is ethane, E-T-H-A-N-E. Only one letter is different, right? So this one E-T-H-A-N-E, ethane. And this one C2H4, this is known as ethene, E-T-H-E-N-E, right? E-T-H-E-N-E. Only the fourth letter is being changed, but that's a complete change of the structure. And the third one, that is C2H2n minus 2, this is ethine, ETHY. Only the fourth letter is changing. See, ETH is fine, AN is also fine, but only the fourth letter is changing, A, E, and Y. So if it is unsaturated, only ethine and ethene will come into picture. If it is saturated, ethane will come into picture, right? So this is an, in, and ine part is common for all the bonds. Not only for the ethane, it's for propane also the same, butane also it's same, pentane also it's same, right? So PR, OP, propane, right? Other one, PROP, ENE, that is propene. And the third one, YNE, right? YNE, that is propine, right? Propane, propene, and propine. So they are aligning with these formulas, right? So if it is propane, not propane, if it is ane, that is CnH2n plus 2. If it is ene, that is CnH2n. If it is ine, then that is CnH2n minus 2. All right. So this is all about naming as well as the saturation, unsaturation of these hydrocarbons, right? So from here onwards, you must be able to understand saturated means all bonds are filled and single bonds. Unsaturated means all bonds are filled, but they are double or triple bonds which can be broken to form new components, right? This is unsaturated hydrocarbons.